will give you this pop-up site, and let's say you can go to this site, and it gives you access to all of the publications. Now, if you are sleepy at or not sleepy at night, go to the website because it's got over 600 pages of information that you can go through and read. And some of it's quite interesting, some of it is not very interesting. So now ASHRAE's guidance is, first of all, is to do no harm, but we want to increase the outside air amount to the buildings and spaces, as well as increase the filtration efficiency, install air cleaning, disinfection technologies, especially UV germicidal irradiation. And if you can't do this with existing HVAC systems, then upgrade with portable HEPA units or upper room and portable UVGI units. Now, resilient, efficient, healthy, and comfortable buildings for people. This is the source of this comes from ASHRAE Code of Ethics. And what we say here is this order of magnitude. For every dollar of design cost, it impacts $10 of construction cost, $100 of operating cost, and $1,000 of occupant cost. And that is the most important aspect of a building is the occupant. And we want to make sure that the indoor environmental quality is safe because it is safe against chronic and acute toxicity, comfort, and then really indoor environmental quality definition is indoor air quality, comfort, lighting, and acoustics. It impacts productivity and learning as well as health. Now, the fundamental truth of ownership, and this is kind of shocks some people, but 5% is cost of construction, whereas 95% pertains to the cost of ownership. Well, what we are dealing with is this 95% cost of ownership. And again, it goes back to our code of ethics. We are supposed to protect the environment as well as protect the occupants of the built environment. So it's a two-edged sword. And this is the challenge that we have. Now, a lot of you thought that you got out of the thermodynamics after you got out of school, but there's also the first and second law of economics that corresponds to the first and second law of thermodynamics. It says if we could create useful energy, we'd have a super abundant resources, but with no pollution and no more scarcity. But the second law says there's no such thing as that because we can't achieve perfect recycling of our resources. So we have to pay attention to the thermodynamic constraints on the economy as well as to the entropy of nature of the economic process. And if to give you kind of an overview, this gives you the flow that we have of energy into our country and where it goes out, who is consuming it or where it is being sent. Now, interesting to me is that we keep talking about our aspect is concerned with new buildings, but new buildings at any one time represent only 2% of the building stock that we have in our country. Whereas 86% of U.S. Building construction expenditures relate to building renovations of existing buildings. Now, the one factor that ought to be striking to you that even with commissioned buildings, this was done by a study by the U.S. Department of Energy, across buildings across the United States, after 3 years, commissioned buildings on the average had lost 30% of their performance. So we see that ASHRAE's research has shown that there is a potential for savings of 10 to 40% by just changing operational strategies. But also the shocking thing is that 75 to 85% of the buildings that will exist in 2030 exist today. So we're looking at an average over the next 30 years of 150 billion square feet of buildings per year to be renovated. Now, U.S. has got 5% of the world's population, but we produce 25% of the world's greenhouse gas emissions. And we've also, 49% of electricity is generated from coal, and buildings account for 72% of U.S. electrical load. Now, 39% of U.S. greenhouse gases is broken down by commercial, 18% and 21% residential. This is our wheelhouse for ASHRAE. So, as well as compared to the transportation of 29%, industry 32%. And the Intergovernmental Panel on Climate Change says greatest opportunity for cost-effective CO2 reductions is making buildings more energy efficient. And to give you an idea of the energy consumption, this shows how the United States consumption compares to China, to United Kingdom, Brazil, and other countries. Now, how many of you are familiar with CBEX, with the Commercial Building Energy Consumption Survey? It was for a few years, it was stopped because of budget constraints, but it has been started back up. On the average, we look at a total of 5,200, over 5,200 buildings. They look at the different 18 different classifications in the climatic zones. And what they look at is how much, what the energy utilization index is for various building types. And this kind of gives you a summary for the different climatic zones for building types of what the EUI number is based upon kilobitu's per square foot per year. Now, the person that is in charge of CBEX wanted me to warn you. And you see that there's some blanks in here. There's some areas that have no numbers. And as engineers, we do not like to have areas with no numbers. And so Paul said that to make sure that I stress to you, areas that do not have numbers, if you try to average the information on either side of these areas, your error is plus or minus 100%. So just take it for what it is. If you don't have it, then don't use it. We see here as a trend from 1979 when 90.1 was initiated. And you can see that it was a fairly drastic drop to 1986. And then there's been some blips, ups and downs. And then you see in 1992, there's a considerable drop. At this point is when LEED came about. But now we see that it's got an upward trend. And the latest version for the U.S. building total EUI is approaching 110 kilobitu's per square foot per year. We're not doing any better. We're doing worse. So now let's talk about the ASHRAE resources that we have to work with. First is ASHRAE Standard 55. And the tables that you'll be concerned with for the metabolic rate, clothing insulation, air temperature, etc., are listed here. And most of us, I hope, are familiar with these charts to show the comfort levels that we are recommended to work between for different temperature and humidity conditions. 62.1, this is something that most people, I feel like, are familiar with, because what it looks at is the ventilation rate procedure, and this is prescriptive or a cookbook design procedure that's covered in 6.2, IAQ procedure, and natural ventilation, which is a prescriptive design procedure. But now, if we look at the ventilation rate procedure, as I say in Standard 62, Table 6-1, you have, hopefully you're familiar with this equation, which gives the rate per person as well as the outdoor rate per unit area, and utilize Table 6.1 to get the factors to integrate into this. For anybody that's not familiar, in the appendix, there are sample calculations utilizing information from this table. If we look at the IAQ procedure, this utilizes Table 6.2 and 6.3. And this information here goes about into the room air or zone air distribution effectiveness, as well as the efficiency of the ventilation system. And typically what you have to do is develop a spreadsheet for the different areas, for the number of people, outside air, breathing area, and then come up with what the effective ventilation rate is. 90.1, 2010, is the energy efficiency standard for the building envelope. You're looking at Table 5.5-1 for HVAC systems 6.8 through 1K, service water heating table, lighting, and performance rating method, which hopefully you're familiar with Appendix G. Now, the one that started when I was president-elect was Standard 189.1. And now this is the International Green Code. It was referenced before, but now the latest version, 189.1, is the International Green, is in totality the International Green Code. What makes it so unique is because it contains not only energy efficiency that we have in 90.1, but also site sustainability, water use efficiency, indoor environmental quality that we see in 62.1, as well as expand in the normative appendix, limit requirements, and the informative appendix. Now, I don't know how many of you are familiar with this terminology, but normative, whenever you see in a standard, anything normative, that means it is a part of the standard. And so the criteria that is listed or stipulated in the normative appendix is something that the code officials will look for compliance. Informative appendix means that this is just for information only, for more descriptive purposes, but it is not formally a part of the standard, and it has to be adhered to. Now, hopefully all of you are familiar with the Advanced Energy Design Guides. There's 13 guides that have been published. The first ones that came out, the 6 that came out, were the 30% guides. And this was started under President Don Culver. And the circulation right now for all of these guides is in excess of 600,000 copies. Now, maybe you don't know this, but what is required before anything that can be published as a 30%, 50% and subsequent guides? Department of Energy provides over $500,000 of simulations for all climatic zones. Now the climatic zones are global. It's not just in the United States, but around the world. If the target savings cannot be achieved in any climatic zone, that guide cannot be published. Now, the guides were developed initially, and I was on the steering committee for the guides when 30% came about. They were designed initially for use in the field. And everything is prescriptive or cookbook. And the interesting thing that you see is that these recommendations pretty well cover a building. You've got the envelope, all the facets of an envelope, interior lighting. You've got HVAC system, and you can see from the 30%, you have 7 to 8 systems, whereas you get to 50%, all of a sudden it drops down to like 3 or 4 systems, because the higher the stringency, the fewer the type of systems that you can utilize. Now, you can pick and choose in here, because under each one of these recommendations are multiple suggestions. Now, the thing that Culver stressed, and I will tell you about these Advanced Energy Design Guides, they are not the way, they are a way. And it gives you, as a designer, latitude to pick and choose anything from the various areas and combine them, just like here it goes into HVAC ducts, exterior lighting, equipment, especially for computers and vending systems, as well in kitchen equipment. You can pick and choose from these different categories, and you will achieve at least the savings, the 30% savings or 50% savings over what the code requires. In fact, the analysis that was done by NREL, as well as the DOE and labs, showed that the 30% savings guide saved actually between 42 and 47% for all climate through the climatic zones, and the 50% guide saved between 52 and 55% for all climatic zones, which I think is quite fascinating. Now, the new one that has just come out, they call them the Zero Energy Building Guides. The first volumes were for K through 12 schools and the small to medium office buildings. Now remember, this is zero energy, not net zero, but zero energy buildings. And that means that throughout the world, from the Arctic to the desert, the analysis said that if you follow for the climatic zone recommendations, you will achieve zero energy buildings. Now, what's targeted for the first quarter of 2021 is Advanced Energy Design Guide for Zero Energy Building for multi-family dwellings. If you haven't seen this, the Advanced Energy Design for K through 12 schools, as well for small to office buildings, this is the front cover. Now, the next thing I want to talk about is the Indoor Air Quality Guide. And this is best practices for design, construction, as well as commissioning. And what is contained in here are 8 chapters with different, that you have 8 objectives with over 40 strategies of how you can achieve the most effective indoor environmental quality. And what I want to tell you is that all of the advanced energy design guides, if you're not familiar with this, all the advanced energy design guides and the indoor uh, quality guide, indoor air quality guide, are free to ASHRAE members. All you have to do is go to the ASHRAE website and download it at no cost. Now, however, what I would suggest that you do, especially on this indoor air quality guide, I would buy a hard copy of it. And the reason for that is that with the hard copy of the IAQ guide, you get a CD. And the CD has over 500 additional pages of material for check sheets, for commissioning, guidelines, as well as design guidance sheets that you can utilize, um, sequences of operation, etc., as a design engineer. It doesn't come with a download. It only comes if you buy a hard copy of it. Okay, now let's talk about energy efficiency for existing buildings. The first thing you should do is establish a benchmark and an Energy Star rating. If the rating is below 75% for an Energy Star, the first target should be to achieve that operation, that level of operation of energy efficiency. Second target would be to increase it to 10 to 30%, maybe on average of 20%. Third target is to achieve performance of the current version of ASHRAE Standard 90.1. Now, in your area, I don't know which version you're on. If you're on 2010, 13, 16, 19, but uh, that should be your third target. If you want to go higher, then go 30, 50%, and 70% beyond 90.1 and possibly 189. And then the last target is to go to net zero or zero energy buildings. Now, let me just tell you that NREL has done analysis that on existing buildings, not new, but existing buildings, that if you get the energy utilization index, EUI, to a 19, you can go the rest of the way to zero energy building with renewable energy sources. So I'll talk more about that in just a minute because of something that we're doing here in Tennessee. Okay, now what I want to show you here is a publication that I was also involved with on the oversight committee, Energy Efficient Guide for Existing Commercial Buildings, the business case. When we first wrote this, it was written, I thought it was an excellent article. It was 600 pages long. It had a lot of calculations and things that I just thought was wonderful, that I felt like that all engineers should have to help you in making existing commercial buildings more energy efficient. We felt good about it until one of the editors of the Harvard Business Review called the director of technology and said, can I talk to you? And they said, sure. He says, well, the guide for business case guide for existing commercial buildings, how secure are you with it? And he says, very secure. She says, well, it won't work. And so we found out from this lady that business owners and managers give you not 3 floors like you've heard on an elevator speech, but they give you 30 seconds to make a point. And if you can't do that in less than half of a paragraph, you've lost them. So this lady on her own rewrote, or basically wrote, this business case for building owners and managers. And so it was done as a result of one of the editors of the Harvard Business Review. And so I would advise you to get a copy of this in talking with business owners and managers, because you are speaking their language. Now, if you want to go through the technical implementation, this is the 600-page one. So we didn't throw it away. We just decided that we're going to publish this as a part of the technical implementation case. And what this includes, you see here, are the various energy efficiency measures. And so it goes building envelope systems, HVAC systems, refrigeration, all the way down to appliances. So Bowman has said that 7 to 28% of savings through low cost or no cost energy efficiency measures, additional 3 to 15% through occupant awareness programs, and lighting is 29%. And so you can have a lot of savings in lighting by with off-the-shelf technologies with less than 1 year life cycle cost savings. 7 to 22% through calibration and monitoring of control devices, up to 15% through equipment changeouts for HVAC systems. And what they've also said is utility expenditures are on the average across the country, a fifth of total cost and a third of the total variable cost. We look at standard 100. This is the energy conservation in existing buildings. And what this does, and I'm sorry for this, I thought we had changed this. There we go. It shows the different controls, electrical, internal plug loads, HVAC maintenance, domestic hot water heating, lighting, envelope, fuel changes, and renewables. And what it is, there are multiple recommendations in here that, again, are prescriptive that you can take, evaluate your particular facility. Now, I'm also involved as a governor appointee to the Tennessee Energy Efficient Schools Initiative. This was initiated in 2008, and it utilized what we had excess lottery funds of $80 million. And it was a combination of one-time grants as well as low interest loans, interest rates from 0.5 to 1.5% interest with a maximum payback of 15 years. But the criteria that we forced upon all the school systems, and there's 147 school districts here in Tennessee, was that our recommendations required compliance with 90.1, 62.1, and 55. All three of these standards, the recommendations, they had to have compliance with these. Because again, it comes back, we wanted efficient, energy efficient, healthy, and comfortable buildings for schools. And now the payback can only come from energy savings. And the way that we had teeth in this is that the savings or the payments were made to the state comptroller. And if the state comptroller found out that a school district was paying out of budgeted monies, they were contacted immediately and told that if you continue to do this, all state funds will be immediately cut off from you. We had one that tried it. And since 2008, we had one school district that tried it, and they recanted very quickly because they couldn't afford to operate without state funds. And what we have found since 2008, that the priority of savings that we're seeing in schools is lighting systems, first, controls, building automation systems, energy management systems, HVAC system upgrades, and finally, domestic water system upgrades. Now, you might want to know, why not building envelope? Building envelope applications take longer than 15 years. And we have been put under the guidance that 15 years is the maximum time that we can allow any kind of financing program. Well, we have created a problem for the state of Tennessee. Our organization, Energy EESI, is under the Department of Education. And we are the only agency in the state of Tennessee's government structure that makes money. And right now, others don't know how to handle it. The comptroller has figured out what to do with it. And so what we're doing, as soon as we get money in, we're turning around and loaning it back out. But we have a pretty good margin of safety. Now, the next thing that we're trying to do is to go to new building construction, as well as try to help buildings get to EUI, existing buildings to get to an EUI of 19. We have Tennessee Valley Authority representatives that sat on EESI that would not allow us to promote zero energy buildings. I know you're shocked at that, but they saw that all their income would be going away. But they have no problem with getting to an EUI of 19. So that is now our new objective here in the state of Tennessee for existing, as well as if we can get additional funding. And again, remember, this fund or this EESI has caused the taxpayer $0 in the state of Tennessee. Not $1 has come out of taxes. It has all come out of excess lottery funds. So there is a way that you can utilize this money for the benefit of the schools. And I might say that on the average, what we have been seeing since 2008, and that's been 12 years, over this time frame, we have saved on the average schools in excess of 25% of their energy consumption costs. So we're striving to go higher, and it's getting more challenging. But again, there is a way that we can achieve this. Now, just to give you some ideas from the standard 100, one of the things that a lot of people aren't familiar with are phantom loads. They consume power when they're turned off. And so it does give you suggestions for Energy Star equipment, power strips, guidance, as well as what can be utilized for office buildings, efficient operation and maintenance items. One of the things that was kind of shocking to some people when they saw this, it was kind of a light bulb came on, is tour the facility at midnight to see what equipment is left on, what operates unnecessarily. And they were surprised to see what was actually left on in the buildings. And then also check for excess ventilation amounts when there's nobody there. So again, spend some time, look at the facility, get a better understanding of how it operates during occupied and unoccupied periods. Now let's look at strategies for improving indoor environmental conditions. So IEQ is control of contaminants. You got different contaminants you see here for the gases, particles, microorganisms, and the control sources, source control, ventilation, filtration, and air cleaners. Now again, I'm going over this quick, and you'll have this so that you can use this as a future reference. And I see that your program on January the 19th will be pertaining to the smart ventilation for health and COVID-19 mitigation. So this just gives you a little head up so you can do some preparatory work and maybe get some real good questions to your presenter on January the 19th. So the mitigation strategies outside air ventilation, increase the ventilation amount if possible, and increase your filtration system from a MERV 5 to 8 to a MERV 13 or 14. And then consider portable MERV filtration. UVGIs in ducts. Pre-flush is recommended. Post-flush, that's optional. And really, at this point, post-flush we're seeing for occupied areas is not really being utilized anymore. But the BAS, building automation system capabilities, are for temperature and relative humidity controls, as well as monitoring and alarms. So what we want to do is filtration on all HVAC systems, and we want to make sure that the filters, you got to make sure the filters are installed correctly so there's no leakage. Because if they're not installed correctly, especially if you're upgrading, you can get a 15+% bypass. And so what this creates is an ineffective filtration system. And then make sure you have a frequency of filter replacement. The pre-flush recommended 2 hours before occupancy, or achieving 3 air changes per hour for 2 hours of HVAC operation. But the key here is not just to turn it on and let it operate, but to maintain relative humidity between 40 and 60%. Demand control ventilation with CO2 sensors, if in occupied spaces, control between 800 and 1,000 parts per million. If they're not occupied spaces, disable demand control ventilation. So guard against any contaminations. Workers should wear appropriate personal protective equipment, disinfect filters with bleach, bag and dispose filters, and when maintenance tasks are completed, personnel should shower, wash hands, and use alcohol-based sanitizers. As an example here, they gave 72 degrees for winter design conditions, 40 to 50% relative humidity to guard against condensation, whereas in summer, 75 degrees F with a 50%, 60% relative humidity. But the guidance is to maintain temperature and humidity design set points per design criteria without reducing ventilation rates. Ventilation rates are key and critical. And this gives you a representation of why this 40 to 60%, this optimum zone that is being recommended here, is for the different types of bacteria, viruses, fungi that cannot occupy in or exist in this optimum zone between 40 and 60%. Okay, ventilation design criteria, again, follow 62.1, and remodeling, increase outside air to maximum allowable for each air handler without compromising indoor environmental quality. That's IAQ thermal comfort. New or replace dedicated outside air system, size it for at least 150% of the standard 62.1 minimum flow. And during this pandemic, disable any demand control ventilation and introduce maximum possible outside air ventilation if possible. If it is not occupied, don't have it on. And then utilize outdoor air sensors or web-based data for outdoor pollution information. Let this be a part of your control factor. Now for energy recovery systems, these next few just show you what a typical system looks like, but then there are concerns. There's 4 different possible arrangements. 3 are recommended because of the bypass air that you might have. The 4th one, you have the outdoor air that is not, you're not bringing in or purging the air properly with arrangement 4. So 1 through 3 is what is recommended. Now, if you want to purge the section, you got to make sure that you have the proper wheel rotation, and then you want to make sure the leakage is going in the proper direction for the outside air as well as the exhaust air. Okay, for air handlers and package rooftop units, for single zone as well as variable air volume, increase the filtration to the maximum MERV that the manufacturer suggests that you can have. Lower the discharge air temperature in the summer, possibly to 52 degrees. Maximize economy operation when possible. Use total supply airflow in each VAV terminal when in economizer mode. Fix, modify, control sequence in VAV system to avoid minimum outside airflow shortage. And install UVC, preferably UVGI, that UVC that has a minimum 1500 microwatts per centimeter. Ensure that no UV lights shine on the filters because the UV lights destroy filter medium. Fan coil units, water source heat pump, ground source heat pump, increase filtration again to whatever the manufacturer says that are allowed. Compensate for heating capacity loss with higher discharge temperatures, check for proper amounts of outside air and operation, and ensure airflow patterns adjust to minimize occupant exposure to particles. So now we look at the HVAC system upgrades and operation guidelines. Verify again, this is code requirements that there's proper separation between outdoor air intake and exhaust discharge. You want to make sure that the building is pressurized, slightly pressurized, and have it verified by a qualified tab testing, adjusting, and balancing service provider. This is somebody that is certified by NEB or by AABC or TAB, TABB. Have airflows and system capacities reviewed by a professional engineer or certified design professional, and make sure that what you are adjusting will not impact the equipment performance. Measure and adjust building airflows to prevent negative pressure differential. It doesn't matter where you are, you want to have positive pressure in the building. Doesn't matter if it's north, south, you want to have positive pressure in the building. And then verify the coil velocities, unit discharge air temperatures to avoid moisture carryover. So now for your filtration basics, which are in standard 52.2, we talk about the minimum efficiency reporting values. Hopefully you are familiar with this. They're based upon 3 different particle sizes, and your typical filter depths are anywhere from 1 inch to 12 to 15 inches for HEPA filters. Filter effectiveness factors are efficiency in location, airflow, and particle sizes. This gives you from the standard 52.2 for the different MERV ratings 1 through 16, the range that they are effective for range 1, 2, and 3 particles. And you can see that's why we're saying that we're recommending a minimum of MERV 8 and preferably a MERV 13 or MERV 14, because that's going to be covering up to 95% of the particulate sizes. And on a diagram, this shows you again the effectiveness of the filtration MERV filters for particle diameter. Now, if we look at HEPA filters, they are 99.97% efficient. And a MERV 16 is the highest efficiency that you can get without going to a HEPA. But now the HEPA filters, they have to be sealed properly in the Filter X so that you do not have bypass. And some may not be able to be retrofitted. So that's why you have to look at get with equipment supplier, manufacturer, and see what can be done. Electronic air filters removed by electrically charging particles. The removal efficiency is this particle fraction removal. And then you have something called a clean air delivery rating that is defining rate for electronic air filters operational capacity. And it's also critical to wipe the wires of any residual buildup because this reduces the electronic air filter efficiency. Gas phase air cleaners, they remove the ozone VOCs, but they contain sorbent materials and not efficient in removing particles or viruses that we're concerned with under COVID. Ultraviolet light, UVC, it inactivates viral, bacterial, and fungal organisms. UVC wavelengths on average 100 to 200 nanometers, 265 is the optimum. UVGI is what is preferred, is UVC with electrical discharge through a low pressure gas in a quartz tube. Otherwise, UVC, you have to protect your eyes if you're working around in proximity of UVC because of the damage it can do to your eyes. And 95% of the energy radiated with the UVGI is at 253.7 nanometers. UVC LEDs are now just coming on the market. They're starting to be produced in 265 nanometer range, and it has minimal UV output versus low pressure mercury vapor lamp. UVC induct, this requires high UV dosages and requires that the airflow rate maximum flow in the duct is 500 feet per minute. And the zone that you have for the irradiant zone for UVC to be operable is a minimum 2 feet. And it's recommended that UVC be coupled with a minimum MERV 8 pre-filter with dust control, and then the highest practical MERV final filter, again, of MERV 13 is what is recommended. UVC induct, you focus on the cooling coils, drain pans, and other wetted surfaces, and you want to locate it 12 to 36 inches from the coil face, and they should operate 24/7. Another UVC is the upper air mounted in occupied spaces at a minimum 7 foot above the finished floor. It requires low UV reflectivity at walls and ceilings, and the ventilation should maximize air mixing and use supplemental fans if ventilation is insufficient. UVC portable room decontamination for surface decontamination. And what this does, it gets rid of specific pathogens. And there are some that are harder to inactivate than the coronavirus, but it is effective in many of these. The photocatalytic oxidation, PCO, bipolar ionization, vaporized hydrogen peroxide, pulse, xenon pulse, and 405 visible light, near UV, and then you have far UV type of filtration cleaners. Now this gives you, the top two pictures show the building UVGI or UVC, that is upper air. And you can see it's 7 feet above the area. It is protected, so it does protect you from your any kind of interference by human activity. Now, the lower left hand is UVC induct, and then you have the UVGI portable filtration that is available for application. So now we look at the building automation system. And let me hurry on here. It's not recommended to completely shut off any of the HVAC systems, even if you place it in unoccupied mode, maintain the relative humidity between 40 and 60%. If the limits are exceeded, then the systems are enabled. Outside air dampers are off, and what you're doing is bringing just the space down into 40 to 60% relative humidity range. If there's partial or limited use areas, have a program override, possibly as suggested as 2-hour minimum intervals. After the override, the system return to unoccupied set points. And then what you need to be able to do is verify these setbacks and setup modes are functional. The systems that are enabled outside air or at a minimum, and exhaust fans are off uh, until it returns to an unoccupied set point condition. Without building automation systems, it requires much more time to set up and monitor. This is physical monitoring, and so you cannot have extreme setback or setup conditions. Best that you can do is 80 degrees F and cooling 60% relative, heating 65 degrees F, 40% relative. And you have to set the outside air dampers usually to a fixed position or minimum position, but all exhaust fans are turned off, physically turned off, except in the restrooms and during unoccupied modes. So the key thing though is without a BAS EMS, you have to monitor the building regularly for condensation, moisture, or fungal growth on HVAC system components as well as the facility itself. Now, how can we guarantee building performance? Well, there's two things that you ought to consider. First is recommissioning, which means that you are commissioning a building that has been commissioned previously, whereas retrocommissioning means that you're commissioning a building that has never been commissioned. And so what I propose is called technical recommissioning, technical retrocommissioning versus process. Technical is testing based, and there's no sampling, no sampling. Whereas in process, that does allow sampling. And there's too many stories about people that have done sampling that others have come behind them and have a very lucrative business correcting what sampling missed. So I would advocate that technical recommissioning, retrocommissioning is the only commissioning approach that you should take. And again, you look at the phases: the planning, discovery, investigation, analysis, corrective action, performance verification, and then continuous building performance monitoring and verification. This item number 7 will correct what I said a while back, is that after 3 years, you've lost 30% of operational efficiency. Continuous building performance verification and monitoring can remedy that. If you're doing your job properly, most buildings, as a commissioning authority, most building owners, as well as maintenance staff, do not have time to monitor as they should. If you do a good job for them, what I've always said, you would have a job for life in this continuous building performance verification and monitoring. If they look to you. Now, one of the things that I do in my commissioning process is when we do retrocommissioning or recommissioning, we take the building representatives around with us and we show them what we find, and then we show them how it is corrected. Again, many of them do not have the time or the capability to do these corrections. And so if you do it correctly and do it properly, you've got a customer for life. Now, validation of commissioning, first party, this doesn't work as a firm or individual verifying the project is the one that did the project. Second party is the firm or individual verifying the project is under the control of the firm that performed the task. That is why I am advocating, like as many of the consultants know, with tab contractors, I know that probably some of the best fiction that you have ever read are tab reports, because they're being conducted for the mechanical contractor. You go out and you do your observation and inspection, and it's nowhere close. So that's why third party validation says that the firm that is verifying the project is not associated with or under the control of any firm performing it or designing it, but works totally for the owner. Works totally for the owner. So the secret of change is to focus all of your energy not on fighting the old, but on building the new. And you have power over your mind, not outside events. Realize this, and you will find strength. These are wise sayings. I just wish I'd come up with them, but you know, if you believe them, implement them, because they're true. They're true to get the most accurate results and the most for your efforts. Now, if you have any questions, I would, if you would, send them to, I guess, Kathleen or Megan or Haley, and they will compile them and send them to me. If ones that I can answer, I will respond. If they are pertaining to ETF, I will send it to the chair of the ETF committee, and he will send it to the various teams that he feels best qualified to provide the answer. Now, in the appendix, let's say there's more detailed information as well as sample calculations for ASHRAE resources, commercial building energy audits, O&M guidance, commissioning of existing buildings, and there's sample calculations associated with it, the BEQ evaluations. The first one was the Salt Lake City Fire Hall. I'll just give you a little bit of background on this one. Salt Lake City Fire Hall, and I know I've got just a couple of minutes. We were called in on this one. It is the main fire hall in downtown Salt Lake City. They had through-wall air conditioning units with electric heat, and so you can imagine in downtown Salt Lake City how costly through-wall air conditioning with electric heat was to try to condition a fire hall. So they replaced it with a VRF system, with a VRF system that, again, they took out all the through-wall units, put in the VRF system, and then when I was called to Salt Lake City to do this training, we were told that the fire chief contacted the Salt Lake City ASHRAE chapter, heard about our training, and said, "We need your help." What we found out was after the VRF system had been put in and had been operating for 6 months, that the utility bills were actually higher than what it was for the through-wall air conditioning and electric heat. And we found out what the problem was, and it was massive. And the fire chief was the one that sat through our review, wanted to know what happened. And in fact, the head of maintenance for the fire hall was in one of the teams. And he's quite simply, the city would not allow us on the site until the building was turned over and the contractor was gone. University of Chicago, Stewart Hall. This is a beautiful building. And we went through this. They had considerable problems, and we found equipment and situational operations that even the university themselves did not even know what's going on. And the final is the Bermuda Government Building. It's called the Global House. Beautiful building. It was a nice venue. I appreciated to be called to Bermuda to do this training. But then what we found out was that in this building, the multiple story building, that there's no return in all of the building. And they had a dedicated outside air system that was specially put in that was actually running backwards. So again, with results that we found, the buildings are now all functioning properly, and they're experiencing the mode of operation that they wanted. Last is renewable energy conservation measures. And what you have here are just some recommendations that you can integrate into your energy conservation measures to get to possibly net zero or get into zero energy buildings. So that's our guard dogs here at the office. Somebody made a noise outside, so I hope it didn't disrupt you. So I guess, Kathleen, I'll turn it back over to you.
Alrighty, thank you very much for that very insightful presentation here. One thing I forgot to mention at the beginning is that we are doing a drawing during this meeting for a $25 Amazon gift card. And so we just took the list of participants here, and Stacy Olson is the winner of that gift card. So Megan, Zach will be reaching out to you to get that over to you. And as Terry mentioned, any questions you have, you can put them in the chat and we'll get those over to them and send those out, the answers via email. So thank you everybody for being on the call today. And we will see you again next month.
Kathleen, I don't see any questions. So do we want to close it out, or?
I guess. I mean, I can probably come up with some questions.